Algebras. Here is Chapter 9, Lesson 1, Day 2. So we are going to revisit what we've been talking about simplifying our radical expressions. And we'll start with these basic definitions of things that we were talking about yesterday. Okay, so a radical is, of course, our square root symbol. Okay, that's our radical. As far as the conversion goes, what's happening here is if you have a number that is raised to the 1/2 power, okay, what that converts to is square rooting that number. Okay, so basically we've taken this exponent and we've turned it into a symbol in itself so we can understand exactly what that exponent is asking us to do. And it's asking us to take the radicand, which is the number under the radical, and it's asking us to treat that number as a product of a number times itself. And we want to know what originally was that factor that is itself, right? What was that factor that's the same, those same two factors? The principal root is the positive root coming out of your radical. And a perfect square has a square root to it, has an integer square root. Okay, so a perfect square is a number that has integer, there we go, square root. Okay, those are our perfect squares. And we were asked to memorize those perfect squares so that we will know them. Some variables can also be perfect squares. Okay, so let's take the principal roots of some of our perfect squares that are currently under the radical here. So this is a we must know our perfect square situation. Again, I'm taking principal roots, so all my answers will be positive, knowing that there could be a positive or a negative of each of these roots. So the square root of 1 is 1. That makes 1 under the radical a perfect square. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. 49, square root of 49 is 7. Square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. The square root of 121 is 11. The square root of 144 is 12. The square root of 169 is 13. The square root of 196 is 14. The square root of 225 is 15. The square root of 256 is 16. The square root of 289 is 17. The square root of 324 is 18. The square root of 361 is 19. And the square root of 400 is 20. Okay? Now notice I kind of left those x's. When you take the square root of x squared, you're asking what times itself gave me x squared? Well, that would be x times x, right? X times x equals x squared. So when I'm asking to take the square root of x squared, I'm asking you to go back to what times what? And that would be x. What times what gives me x to the 4th? Same value, right? That would be an x squared. What times what gives me x to the 6th power? Well, that would be x cubed. Are you seeing the pattern? What times what gives me x to the 8th? That would be x to the 4th. Do you see the pattern? Right? X squared times x squared gives me x to the 4th, which think of it this way, x squared squared. Multiply, add, 1 plus 1, 2, 2 plus 2, 4, 3 plus 3, 6. If you think of it this way, x cubed squared, x to the 6, 3 times 2, 6. See that? That's where those are coming from. So that goes back to our exponents rules that were chapter 6, lesson 3. So it's just making sure we're applying those exponents rules. And now we're just going in reverse. Okay, now we're just going backwards with those. So yesterday, I introduced you to this idea of simplifying radicals by never leaving a perfect square under a radical. Anytime you have a perfect square, you have to take its square root and bring it out from underneath a square root symbol. Okay, but that also applies to perfect square factoring. So it also applies to any time you have a number under the radical that is evenly divisible by one of your perfect squares. You can't leave that perfect square as a factor either. So what we're going to do is just continue to practice this method of taking square roots, okay? Now, if you have something like radical 63, well, 63 itself is not a perfect square. Notice it's not one of these under a radical that comes out to give me an integer when I take its square root. So 63 itself is not a perfect square. However, it is evenly divisible by a perfect square. And what I do is I only think of perfect squares to take and divide into that radicand. So if I weren't sure if 63 was evenly divisible by a perfect square, I would say take 63 and start by dividing it by the first potential perfect square, 4. Nope. Then I would try 63 again and then divide it by the next perfect square, which is 9. There we go. And now I can see it. And so what I do is I take radical 63 and I divide it into two radicals that are being multiplied together. So two radical factors. And those two radical factors are a perfect square radical factor and the resulting leftover radical factor. So you divide out that perfect square and you take its square root. What's the square root of 9? It's 3. Can you take the square root of 7? No. That's why it's the leftover and it's always going to remain under the radical because it is not a perfect square, so I cannot bring it out. And so now I bring that down multiplied by my coefficient 3. So my answer is 3 radical 7. And we practiced saying 3 radical 7. So when you see that, you know how to read it. Give that a try. 3 radical 7. Let's just do some more practice. Last time I did the odds. So yeah, why don't I do the evens this time and leave you the odds? And then again, we'll practice again on the homework. And there's a couple questions in the homework at the very end that head back to chapter 1, lesson 1, and remind us about rational versus irrational numbers. Now, when you see a radical, you should immediately ask yourself, is the radicand a perfect square? Okay, 84 is not a perfect square, but is 84 evenly divisible by any perfect squares? Well, let's try it. So 84 divided by 4 is, 21. There's a perfect square that divides evenly into 84, my radicand. Now I need to consider, with my leftover that would be 21, are there any perfect squares that divide evenly into 21? Think of 4, then 9, then 16, and then 25. Now you're too big. No. I know that seems like a big number to have as your leftover, but it is. It is not divisible by any more perfect squares. So you divide radical 84 into a perfect square radical and a leftover radical. The perfect square factor goes under here. And now 84 divided by 4 leaves me my leftover radical here. You take the square root of the perfect square. Square root of 4 is 2. You bring the leftover radical attached by multiplication with the 2, and your final answer is 2 radical 21. Say that. Okay. And yes, again, notice I check my leftover to be sure my leftover is not evenly divisible by any perfect squares either. I can never leave a perfect square under a radical, even if it's just as a factor. Notice I am labeling perfect square leftover, so I am remembering to take the square root of the correct one, because that's where I see a lot of mistakes. So if you are struggling with that piece, label your radicals. 32. I know right off the bat 32 is evenly divisible by 4. However, my leftover when I divide 32 by 4 is 8. And I know that 8 is also divisible by 4. So this is not the biggest perfect square that divides evenly into 32. Could I use it? Sure. But then I'd have to go through this entire process a second time. Okay, so let me show you what that looks like here, and then I'm going to show you what finding the biggest perfect square from the get-go would look like. So I'm going to say, well, I know 32 has a factor of 4, so I'm going to divide it into perfect square and leftover. 4 being my perfect square, 32 divided by 4 is 8 is my leftover. Okay, well, take the square root of 4, I get 2, and then I bring this radical 8 along, and there should be a big red flag. 8 is still divisible by a perfect square, so I'm not done. I got to do the same process a second time. So now let's see. I bring my coefficient first, then I divide radical 8 into a perfect square and leftover. 8 is evenly divisible by 4. 8 divided by 4 is 2 for my leftover. Take the square root of the perfect square. Now multiply these two coefficients together, and you get 4 radical 2 as your final answer. Say that. Okay. Now, what if when I had started right here and saw that I had a leftover that still could be divided by a perfect square, I kept trying and found the biggest perfect square from the start. So let me take 32 and divide it by 9. Let's see how that goes. Oh, no. Okay. Now let's try 32 and divide it by 16, the next perfect square. Aha. Now I found the biggest perfect square that divides evenly into 32. So what if I did it originally like that? Perfect square of 16, leftover of 2. Oh, sorry, leftover, 2 under the radical. Take the square root of 16, I get 4. Bring the leftover radical to multiply by it at the end, and look at that. One step to get to the correct final answer. Okay. Let's try the next one. Perfect square, 4. 44 divided by 4 is 11. That's your leftover. Take the square root of 4, you get 2. Are you noticing a lot of the same perfect squares as factors? Well, yeah, that's because of the types of numbers we're using and the fact that there's not that many perfect squares, which is why I ask you to memorize them, because then it makes this process so much easier every time. My final answer, 2 radical 11. 2 radical 11. Say that. Okay. There's a coefficient in front of radical 96, and it's a negative 1. So what I do is I just make sure that I'm carrying that with me when I divide 96 into its perfect square and leftover radicals. So let's take 96 and let's start out with 4, as we do, and we get 24. Let's keep going because 24 is divisible by a perfect square, right? So let's take 96 and try dividing it by 9. Next perfect square. No. Okay. 96 divided by the next perfect square. That's 16. Aha. 16 leftover 6. 6 is the final leftover, not divisible by any perfect squares. So there we go. Square root of 16 is 4. And you need to multiply that by the negative 1 coefficient that was already there. You get negative 4 radical 6 as your final answer. Say that. Negative 4 radical 6. Have you practice that so you are reading these correctly? The radical is an extremely important piece of what you need to be reading because that is a symbol that needs to be a part of how you are processing what we're doing. These are all irrational numbers, okay? These are irrational numbers. These are non-repeating, non-terminating decimals when I actually plug them into the graphing calculator, okay? So just to prove, negative 4 radical 6 comes out to be that. Do you want to be dealing with that? No. So this is the cleaner way to look at it and know This is irrational. Okay. All right, last one of these, and then I'll pause it and let you try these other ones. We've got 4 as a coefficient already, but let's divide 18 into perfect square and leftover. 9. 18 divided by 9 is 2. Great leftover. The square root of 9 is 3. So out front, 4 times 3 gives me my 12 coefficient, and my radical 2 remains as my leftover. So my final answer is 12 radical 2. I'm going to have you pause it. Okay, so we're going to pause here. Let you try 1, 3, 5, 7, 9. See how you do. And then again, we'll go back through the homework one more time, practicing all this so that you've got how to simplify a radical down pat, because this doesn't go anywhere. It's one of those things like the rest of this here that carries forward. And we're definitely going to use this right away in the next chapter. So try these. Give it a try. Welcome back. Let's check our answers. I'll read through them. So we are practicing again how to say these answers, right? So 3 radical 6, 2 radical 3, 7. 49 is a perfect square. Take its square root. That's rational. This, by the way, the only one here that's rational. -3 radical 3, -18 radical 5. Okay. Practice again with the homework. Memorize those perfect squares. Remember, that's all you're using as factors. It's just try 4, then 9, then 16, then 25, then 36, then 49, right in a row. Okay, that's what you're using to find that biggest perfect square factor. Okay, if you get to a perfect square that's larger than your radicand, well, I guess there's no perfect square factor, right? Memorize the perfect squares. Practice with the homework. Let me know if you need anything. Again, big deal concept, carries with us in the next chapter and all of our maths this point forward. Good luck, guys. I'll be seeing you soon.